Hi, my name is Ademola Ibiranke, and this is a presentation on time series data analysis using the R programming language. So for this project, I'm going to be working on three data sets. The J17 data set, which is the daily eye historical data set of the Edwards Aquifer, which captures water elevations, daily water eye elevations over a period of year 2023 to I think year 1927 or 1932. The second data set is the Comal data set, which is also a historical data set of the Comal Springs at New Braunfels. It captures historical discharge at this spring from 1927 up to the year 2023. And the third data set is the San Marcos data set, which also captures discharge, daily discharge of the San Marcos Spring between the year 1956 and 2023. So this analysis is done using the R programming language and in the R studio environment, development environment. So in order to do this analysis, a number of packages are required, and the first step is to either install or just already have them, just load the packages. So for time series data analysis, there are four major steps that needs to be would have to be gone through. The first step is to explore the data, and then you need to understand the structure of the data of the time series. You would have to decompose the time series and also perform statistical tests to confirm, the structure and the nature of the time series data set. So for the sake of this presentation, I will be jumping to the combined analysis of those three data sets. And if I have time, I'll go back and try and do individual presentation for each analysis done on each data set. But to start this presentation, I'm going to be explaining the analysis using the combined, using a combination of those three data sets in one R Studio script. So to explore the data sets, you will start by, of course, creating a directory and then reading your data using the R script. And then these are all part of the exploratory data analysis, where you view the data, arrange the data. So in this case, I trained my data set to make sure that I have the columns that show just the dates, the date column or the year column, as well as the values for each date. And so having done that, I converted my dates column into a time series. In order to do that, I had to convert the date column to a date format, and then I extracted the relevant time data set, the relevant column. I selected the relevant column. So if you're looking at this code over here, I'm performing the same operation on each data set from step to step. So over here, I have I'm working on the J17 data sets to extract the relevant time series column, And this over here is the Comal data sets. I'm trying to work on the column, the year column for the Comal data set. And over here is the San Marcos data sets referring to the column that addresses the date time. So the data exploratory process for me culminates in just viewing the summary of the data. So to view the summary of the data, you will be able to see how the data is distributed. You see the minimum value, the first quadrant, the value in the first quadrant, the median value, the mean, the average value, the third quadrant value, as well as the maximum value of in this case, for the Edward, the J17 data series. So having then, summarized the data set, I moved to trying to understand. Well, I want to jump quickly to decomposing the data set, because at the decomposing stage is where we are able to actually see what the trend, how the historical data trends, or what the trend is, and what the seasonality is, and also what the randomness of the data sets look like. So it's going to go to where, okay, so over here, showing the trend, the season, as something there. But I was, so decomposing the data set helps to view, the trend, the season, and the randomness of the data set. Now, having plotted, so I conducted the autocorrelation of this data set, and I was able to view. So over on this step, actually, what I did was, so part of this is part of the statistical tests where I did perform the Kalman test to see to able to just remove to see the correlation, or the correlation of the data. Well, yeah. So so in doing cross correlation, I was able to view what the correlation is between the three data sets, and so the results show that for the zoo, the J17, which is the Edwards data set, and the Comal Spring, the cross correlation between them is somewhere between so the range is from 0 to 1. The values close to 0 show the minimum amount of cross correlation, and values close to 1 show perfect correlation. So in this case, my values are close to 0 is probably about 0.02, which shows very low cross correlation between those data sets. For the J, it's similar for Edwards and San Marcos data sets. The correlation there is also close to 0.02. And for the Comal and San Marcos data sets, the autocorrelation there is about the same thing. So like I said, there are 4 major steps to doing time series data analysis, and usually you're able to view trends, seasons, randomness, and noise in the data sets. The codes for the entire work, the entire analysis, I'm going to be posting on my GitHub page, which will hopefully provide more information. But this is just to show initially how time series data analysis can be performed. Thank you.